Hello guys, welcome back. Today we'll be learning about HashMap implementation. HashMap is basically implemented using an array of linked list because HashMap is implemented using hash table and hash table is internally implemented using array of linked list. So we'll be using that approach to make an HashMap and uh, this question is uh, there in lead code as well. Okay, you have to implement the put, get, or remove there, and it's also there in geeks for geeks. You have to implement the put, get, or remove. Okay, but the thing is, we have integer key and integer value in both of them. Okay, but what I will be doing is we'll be making a generic HashMap class so that we can use it for any type of key value pairs, any data type, be it integer, string, float, boolean, anything. Okay, so let's go. So first of all, we'll just let me just close that and this. So first of all, we'll just import everything in case we'll be needing, and we will be needing the linked list because we are using array of linked list, so we'll be needing linked list operations. So let's go ahead and make our class HashMap. Okay, HashMap, and actually I want to make it a generic type of key will be of type K and value will be of type V. I want it that way, and now we will create a class for our HashMap. Okay, first off, let's create a node inside this, which will be private class node. Okay, okay. Now the node, each node in a linked list, it will have two values. First value is its key value. The second one is its value. I mean, first will be the key, k key, and then will be v value. Okay. We have k key and we have v value. Pretty simple. Okay. Now after that, we have to make a constructor for this. Okay. So let's make a constructor. We have constructor for node, that is we pass k key and v value. So we have this dot key becomes key and this dot value becomes value. As simple as that. Okay. Now this is our node, and then we'll have some other operations inside our HashMap class. First operation will be the put operation. The next one will be the get, and the last one will be the remove operation. Other than that, we'll also implement the rehashing since we are doing uh, an array of linked list. In case that we reach a point where we are getting uh, a non-constant time. Okay, basically what we'll be doing is um, I'll I'll tell in short. We have capital N as the array size. Okay, now the array, every box, every cell in the array contains the head of a linked list, right? So we'll have N. N is the number of nodes, right? Number of nodes, total number of nodes. So on average, each cell of the array has n by n nodes in the linked list. Is that not correct? If I have 6 nodes and I have an array of size 3, so what happens is that uh, I will divide 2 nodes each. Okay, just assume that. So each cell of the array is pointing to a linked list of 2 nodes each. Okay, that sounds pretty simple. So we'll have n by n as our value. Let's call it alpha value, or let's call it alpha lambda, whatever you want to call. Let's call it alpha. Okay, we have alpha. Okay, so our stuff is, and alpha, remember, should always be less than equal to a threshold value. Okay, less than or equal to a threshold value. Why is that so? Consider we have a lot of number of nodes, and first thing we have to do is we have to figure out in which of the linked list out of capital N size linked list on which index is our linked list present. For example, if I have to search for a particular key, I'll first have to find out its value, find out its index in the array, and then in that array I have to traverse the entire linked list until I reach that key, right? So finding that array is pretty simple. We can do that using the hash code function, which we will be implementing while doing the put operation. But while traversing the linked list, what we do is we go in a linear fashion, right? So you might be thinking that this should be taking a linear amount of time, but we can argue that this will actually take constant time. Why? Because first we skim it down. We do not travel on n. We do not travel on total number of nodes, right? We only travel on the number of nodes that is present in each linked list, which is n by n. And since we have already told n by n should always be less than or equal to threshold, if I say my threshold value is 4, that means at most I will travel 4 nodes. And if I don't get my key within that 4 nodes, then I'll either put that key there or update my key if I get it. But I will travel at most 4 nodes, which is still constant. Okay. Now, for the re sake of this in linked list implementation, we'll be using a threshold value of 2. Okay, 2, and we'll be using a float or double, you can say. Now that is because we want to always calculate if our linked list, our array of linked list is full or it is being overfilled or it is now unbalanced, and it will not be doing its work in the given amount of time, which is big O of alpha. And since alpha is a constant, we can say constant time. But if that is not the case, then we have to change it. We have to convert it into a bigger array. Okay, and we have to put all the nodes into the new array. So that way we do not uh, overpopulate any linked list, and we also need to update the size of the array in that case, and number of nodes stays the same. But now since the array size increases, like this capital N increases, what happens? If the capital N increases, then our alpha value decreases, and since alpha value decreases, it will at some point get reduced by uh, you know reduced below our threshold level. So that is what we'll be doing. We'll be doing three major options and two simple options. I'll rename what options we'll be doing. The first one we'll be doing is the put option. Okay, we'll first do the put option. The second one is the second one will be a get option. Okay, put and get, as simple as that. Third one we'll be doing is a rehash function. Like we have to rehash it in case our array list is full or it is giving non-linear time, then we'll have it is giving non-constant time, then we have to rehash it, so it now is settled in a new node, so it gives a better time. Then we'll be implementing the remove method, and with that uh, there are two more simple methods like key set method or entry set method, where we have to just return the set or array list or array of the key values, and then we have the empty set. I'm sorry. Then we have the is empty function, which will return whether the map is empty or not, whether it is populated or not. Okay. Now these are all the functions we'll be doing, and we'll be doing it in a generic way. Like we'll be using k data type for key and v data type for value. So we can use pretty much anything we want, integer or string or whatever. And we just want our hash map to be generic and can be, and the data type should be uh, instantiated when we call for an object. Okay, that's what we want when we are talking about generic values. Okay, so with that, let us begin. Okay, so first off, I'll keep some values that we want as globally available throughout this entire class. Throughout this hash map, I want these variables to be available. Some of those variables will be, let's say, private int and capital N. What is the capital N? This is the array size, right? This is the array size. Then I have private int small n. Which is the small n? It is the number of nodes. Or capital array size, we can also call it as number of buckets, right? We can do both of this. Okay. And now since we are going to uh, use an array of linked list, we have to declare an array of linked list as well. Okay. Private linked list we have there. Private linked list, and we want linked list with the data type node. We um, okay. Now we create. What did happen? No, it's fine. Oh, there seems to be some issue in my keyboard. Okay, now it's fixed. Okay, let's call our array as buckets. Okay, it's an array. It's an array, and it will be of array of size n. Okay. Now remember, now see this. I have only declared it. Okay. So at this point, you can imagine the buckets, this buckets variable as a storage to the memory address. It is not really a pointer. It's just a reference, and it does not have any size or any value to it. It just has an arbitrary memory address to it. Okay. Now we do not want to create an object just yet, just as the program is created. We want to create the object when the object is called. Okay. So to do that, I have to make a constructor for that, right? A constructor for our hash map. Okay. So let's make the constructor, and inside the constructor, I will instantiate this buckets array. Okay, let's have public uh, hash map since this is the constructor. Okay, and it does not need any uh, arguments inside it. And when this is called, let's instantiate the size of the array as, let us suppose, 16. Okay, 16 might be too much. Let's say 4. Okay, then the number of nodes will be done when we put something or when we remove something. So we do not need to update that here. What we need to do is we need to instantiate the buckets, right? We have buckets. Okay, now this will be instantiated to a new linked list of size n. Okay, now remember this class. Okay, this class, I mean, sorry, this statement, this will work. This statement will work, but when you try to run it on your PC or your compiler, it will throw a few warnings before it runs, right? Because here, if you see, we just created an array of a linked list and we did not pass any data type. Our compiler wants us to pass a data type of the array, data type of the linked list that we want to create an array of. But we have not passed any data type, so it will throw warnings. It will still work. It is a warning, it is not an error. There's a difference between a warning and an error. It will still work, there's no issue. But if you do not want to see such warnings, want to keep your terminal clean, you can just suppress the warnings. Okay, suppress warnings, and you can type uncheck. Okay, now that's a linkage, and it will just suppress the warnings and not show any warnings. We'll do while we instantiate the class. We'll show you. I'll show you how this works. Okay, now. Okay, and after we have done this instantiated this buckets class, this buckets array. It's not a class, it's an array. I'm sorry, I'm calling it a class but out of habit, but it's actually an array. An array of what? An array of linked list. But now it's only an array, it does not include anything, right? So I want every cell to include at least one empty linked list. That will make things easier for me. Okay, because if I don't have that, then uh, for every cell I have to make a new one, and then I go ahead and do all the operations, which I do not want. I want them to be an empty linked list by default. Okay, so what I'll do, is I can use the for loop. Okay, I can use the for loop till buckets dot length you can say, or capital N you can say, both are the same thing. Okay, then you can pass this dots bucket of I will become a new linked list. Okay, that's all it takes. We just have to instantiate new linked list there, and it will create an empty linked list at every cell of our bucket. Okay, so now we have an array of size 4, and at each cell we have an empty linked list. Okay, that's pretty much it. Now, since our global variables are done, we have made a node class and we have made a constructor for our HashMap class. Let us go ahead and do the operations. Okay, the first one we'll do is put. So let's say public, and when we want to put it, we don't have to return anything, right? We put something, we do not return it. So it should be of void type. You can return like the value, return the value, but that is pointless because if we are putting something, we are inserting it. Okay, we know the key and value, or you can do it of a boolean type if you want. Like if you was able to insert it, return true, otherwise you can return false, but generally it should be able to insert it. Anyways, okay, now what should we insert? We insert k key and v value, right? K key and v value. Okay, now the first thing we want to do while inserting, okay, now remember, for any key value, the key should be unique, right? The key should be unique. So for any key value, we have a hash function. That hash function converts our key into, let's say, a bucket index. Okay, bucket index, BIDX. Okay, bucket index. We have a bucket index. Let's say BI for short. Okay, we have a bucket index. Okay, let's say it is a hash function. It is a hash function, and we pass the value of key. So what happens? We get the bucket index from this function. As simple as that. Okay, we get the bucket index. And what will you do with the bucket index? We want to find the proper position for this element, for this node, right? First, we need to find its proper linked list out of the out of capital N number of linked list. On which linked list should it go? For that, I need to know the index on which it need to go. And in index, we are talking about the array index. Okay. Now, after I got the array index, I want to put it in. I want to find its index in the linked list. So let's say LLI linked list index. Okay. Linked list index. Let's say we have a linked list search. Okay. Linked list search. We have a function as linked list search. Okay, and we pass, again we pass the key, and we also pass the current uh, bucket index. Okay, so what is the this function does? This function, we get back, try to think about it, we get back the index of the linked list on which we want to store the key. Pretty simple. Okay, now there are two cases. Either we find an index where we are able to put the key. Okay, let me just quickly change the theme so it is pretty visible. Yeah, now the comment should be pretty visible. Okay, now think about it. We first found the index at which the linked list is. Now we find the index at which our key needs to be inserted. Okay, now there are two possible situations here. The first one is if the key actually exists. So what do? We update it. If the key does not exist, let's say we return -1. If the we did not find any index, we'll return -1. Okay, so in case we return -1, which means our key did not exist and we need to create a new key. Okay, and we'll add that at the at the end of our linked list. Pretty simple. Let's do that then. Okay, now let's say if, what do I say? if linked list of index is not equal to -1, okay, which means it is valid. It is valid. If it is equal to -1, that means the key does not exist and we need to create a new one. Now since it is not -1, it exists. So I need to first access the node. We have node, let's call it node and access it as buckets bi dot, no, it's not get last, it's get LLI. Now how so? First we go to the proper cell at who, like proper linked list, and then we go to the proper index, the index that we get. Since it's not -1, it has some value. Okay, so we get to the proper index, and after that we insert there. Oh, sorry, we change the value. Okay, this means we found the node and we need to change the value. We change the value. Node value becomes value. Like this value is the past one, and this node value is the original one. Okay. Now else, if it is -1, what do we do? It's pretty simple. What do we do? We create a new linked list and insert it, prelude new node for the linked list and insert it into the proper position. What is the proper position for it? Proper position for it is buckets of bi dot linked list. Actually, we can directly add there because since our data does not exist, we can just append it at the last site. So we can add new node key comma value. Very simple as that. Okay, and remember, whatever we do, okay, whatever you do, you have to update the size of the mod we have to update our uh, number of nodes, right? Now tell me, initially our number of nodes initially was 0, right? Our number of nodes initially was 0, but should we update the value, update the number of nodes for both of these cases or only one of these cases? If you think about it, if we change the value, if you only change the value, we are not adding or removing any new node. We are only changing in one node. So that means the number of nodes stays the same. But if we add a new node, okay, we created a new node, which means our size get updated. Okay, you can write n plus plus or this dot n plus plus, both of them work fine. Okay, because we are referencing to the current one. But this might throw error for some cases if you did not initialize. Uh, yeah, so let's just initialize this dot and become 0. Okay, which means we have 0 nodes in the beginning. Okay, as simple as that. Then we have, okay, now before we proceed, let us just simply uh, finish this uh, hash function and the linked list search. Okay, it's pretty simple. Both of them have to return an integer int hash function, and this should be, let's say, private because I do not want this hash function to be accessed outside this class. And what do we pass here? We pass a k key, right? Okay, and what should it return? What should this hash function return? It should return the like it should return the convert the key into a, using some hashing algorithms, it should convert it into a number. Okay, now let's say int number is, we use the hash code function. What is the does is it takes any key you pass, any data type, and it converts it into like what's the okay, says it's not applicable for the data type key, but we'll work around it. There's no issue about that. Anyway, okay. So what we do is we pass the value of key, and we want our hash function to convert this key into a number. And actually, I should not write it this way. I should write it as key dot hash code. That will be better. Okay, now that works. And now this number can be anything from negative to positive to anything. Okay, so first thing I want to do is I will have to return the absolute value for this. Like I have only positive key, right? Positive indexes. That should be my first priority. I have math dot absolute. The second one is I want this to be inside the size of my array, which is 0 to n minus 1 only. Now, to get 0 to n minus 1, should I just simply use the modulus operator and n here? Will this not make it lie between 0 to n minus 1? Will this not work? This will work, so I am keeping it that way. Okay. Now, this is the thing that we are returning to the hash function. Now, how? For example, you have a key and you return this value, which means first we converted the key into some integer, took its absolute value, and then found its relative position in the array 0 to n minus 1. Okay, that is one of the indexes. That is what we are returning. Okay, it's a simple hash function. Then we have search in linked list, which is simple linear search. Let's just do it as well. Private in linked list search. Okay, private in linked list search. And what do we pass here? We passed key and we passed the um, bucket index also. Now let's do it. Like, let's go ahead and perform the linked list search, which is pretty simple. It just seems like it, it technically is a linear search in a linked list. Okay, so what we do is let's say we have linked list. Let's first get the linked list at the bucket index. Okay, we have linked list is equal to buckets of bi. We have passed bi for that. Okay, and then say lli. We have to find the lli, right? Then say lli. Okay, now for int I becomes 0 to I less than ll dot size I plus plus. So this is a pretty simple loop. We don't need to use any current next. We can simply use this loop and we can we can assume that Java linked list will go to that position for us. Okay. Now at each position I need to find the node, which is ll dot get of I. Pretty simple. Get the node at I index, and if node key equal to a given key which we have passed, that means we can return this lli. Okay. Otherwise otherwise I should just simply update the lli, right? As simple as that. And at the last, if we do not find it, we just simply return -1 as we have found before. Okay, that's what it means here. Now, while doing the put key, okay, you see, while doing the put operation, I also told that we'll be implementing the rehashing function, right? So after you have done with the inserting of the key, what we'll do, is we'll calculate our alpha value. Double alpha is n by n. Okay. Now since n and n both are integers, I should typecast it to double. Okay. Now what happens? We have a threshold value to check for. If alpha is, I told the threshold value should be less than equal to, I mean the alpha should be less than or equal to 3. So in the case that it is not less than or equal to threshold, let's say for 2.0. Now if since it's double, we'll take it 2.0. If we write 2.0 f, it will be float. We can do that too. Okay, which means we need to rehash. Otherwise, we are good to go because we are still under big O of n by n, which is big O of alpha, which is constant. But since it passes ahead, what to do is we call the rehashing function. Rehashing, okay, rehashing, okay, and that will be a void function. Other than that, it's okay. Now this also works fine for the put method, and now we have to implement the rehashing method. Let's say private void rehashing. Okay. Do we pass anything? No, we do not pass anything. We do not need to pass anything, right? First thing we do is uh, we create a linked list. Why are you creating a linked list? We are not actually creating a linked list. We are creating a linked list node. We are creating. What we will be doing is we will put a new array into the place of size double the old one. So first we need to access the old one. Okay. Let's say previous bucket is my size is my old one, and this was array, right? Okay. Then we have we store our buckets value here, and now we'll create a new one, and we'll put that into buckets only. Okay, which is new linked list of size n into 2. Okay, double the size. Okay, now this, you see, this will also be throwing an error because of the same reason. So we can also suppress warnings here and type uncheck. Sorry, I forgot the symbol. Okay, now that will work and it won't throw any warning. Now remember, this suppress warnings does not hinder your compiler to run it either way. It will run it either way, but just with a few warnings at the beginning, and then it will run it. Okay, and now since we have done it, we have to update our n as well. N becomes n into 2, as simple as that. And we have to make a new array as well for int to int, not with bucket length, it's current bucket length, or you can say n because we updated n already. And we have to create new linked list at all position, new link I'm sorry, new linked list. Okay, as simple as that. Okay, now what to do? Add from old to the new one, as simple as that. So for the first loop, I'll go to every linked list because we have an array of linked list. I'll first traverse the array, then I'll traverse the linked list. Okay. For int I, yeah, for int I 0 to with bucket length. Okay, we are going for the previous one. Let's say we have linked list of node. We get it. Linked list of node ll is equal to with bucket of I. Okay, and then we go for everything in that linked list, which is ll dot size. Okay. Now what happens? We create new nodes. Node is new node with the same key value, which we can actually do it by using ll dot get I, which is more simpler. Okay. And then what we do? We add this into the new one. Put put of key value. What is key? Key is uh, node dot key, and this is node dot value. Okay, simple. Now those for loops take care of the rehashing, and this rehashing actually takes much bigger time complexity, but it is you can see every time it is called, it is making its size double. Okay, which means it will not be curled very much. We started with 4 size, it becomes 8, then it will become 16, then 32, then it will become 64, then 128, and so on and so on. Okay. At this point, there as much nodes we keep on adding, the size will increase exponentially. Okay. So this hash function will be called very less, and we have an put method in big of 1. Now let's make the uh, get method. Actually, first let's make the boolean method about contains key. If we have a key, we should return it. If we don't, we have to just return false. Okay, and it's pretty simple. It's the same code as everything else. We first find the like bucket index, then we find the linked list index, and then we search. If it is 1 minus 1, then we return true, which means it contains. Otherwise, we return false. Okay, simple. Now, similarly, we have another method which is the get method. Public, and for get, we'll get a for every key we'll get the value, right? And key is of type K, value is of type B. So it is get we get, which is we pass the key, we get the value. Okay, as simple as that. We do this. Okay, we find the index, and then uh, we do the same if else condition. Okay, if it is not minus 1, then we have to return like that value, so we need to traverse that is equal to bucket. Okay, buckets of bi dot get lli, right? And we have to return the value for this, return node dot value, and otherwise you can simply return null since it does not exist. Okay, now we have done the get method. We have the remove method. Public, we would remove a key. Okay, while removing we want to uh, know which one we remove, the value of the one that we remove, and it's pretty much the same. It's pretty much the same. Okay, I'll first find that one. After I find that one, I'll get the I'll get the node. Okay, and actually we can just simply use remove and not get here. Okay, that will do the task. And one important thing is we have to decrease the size. Okay, 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 we have to decrease the size. Okay, otherwise return null. Why? Because we did not find it, so we did not delete it. Simple. Now there's two additional functions. Let's first do the public is empty. Its public boolean is empty. Okay. What it does, it simply returns if n equal to 0. If that is true, it means it is empty. N is number of nodes. Remember, n is number of nodes. Okay. And lastly, we have the key set function. Public, and let's use array list because that's pretty flexible. Public array list of what? Array list of node dot key, and keys of type K. Key set, if you want entry set, you can write K comma key. It will work. Key set. Okay. What we'll do? We'll first make an array list of what type? Of K type. Let's call them keys, and initialize them. Now, what to do? We go to every index of bucket. We find the linked list for it. I think it's linked list node of L is equal to buckets of I. Okay, and for every L dot size, we have each dot add nodes key. And what is node? The node is the one at get I, right? ll dot get I. So we can simply do that using a for each loop, which is node in ll works. Okay, and after we are done our operation, I'll return our array list key. Okay, so these are all the functions that we have implemented, and let us actually call the main method and try to use this class. Okay, now we have, first we need to make hashmap. Okay, this hashmap. Now remember, this the one I am using is my own, the one I have written, and not the one in the Java util, right? If you want, we can just simply write linked list here. Okay, and linked list and array list, because that will make sure that we are not using the hash map. Okay, in case there is any doubt about that. Okay, so let us say we store string comma integer in our map name mp. Okay, mp, let's put a, and we put 100. mp dot put b and put 2000. p dot put capital A again, and we put some random values, and lastly we have dot put let's say c for some, again some random value. Okay, okay, now let us now here first way, what happened. Okay, we have to make it like this. No enclosing of time. Why is this not available? Is it because I made it private? Should I make it public? Okay, there's some issue. Just a second, let's fix it here. No issue. HashMap, uh, oh, I got it, I got it. It's because we have to actually do it like this. String, integer, we have HashMap. What HashMap do we have? Yes, we have HashMap only. And then it should be new HashMap angular bracket, right? Why is it still throwing an error? Why is it in blah, blah, blah. Okay, we'll see it later. Anyways, we are able to instantiate it and continue our work. Okay, now what we'll do is we'll try to use the other options as well. Okay, for example, the remove and the other one. First, let's try the first. Let us try the method of key set. Key set is key. Key is string. We will get uh, mp dot key set. Okay, mp dot key set, and Let us go through it. String of k of keys become, let's just print the key here, the key value here. Okay, but print, what should we print? Let's just print key. I'm sorry, it's k, and along with that we'll also print the value, which will be mp dot get key. Okay, now that is key and value pair right there been printed, and let's do it in new lines. Okay, then let's print stuff like some particular key, like the one we updated for a, which will be mp dot get a. A is actually a string. Okay, next we have, let's try to remove the value. mp dot remove, which one should we remove? Should we remove b, because that is a small one. Now let us try to get the same one that we removed. mp dot get b. Control Alt N. Let's run it and see the code. Non-static. Okay, that's the issue. We have a static method, but we are calling a non-static key, which is this public static class. Now this should work. Okay, here we see. First we pushed, we inserted four values. Okay, and of the type A, 100, B, 200, A, and so on, so on. Then we got the key set, and when I try to print the key using the key set, we have K, A, B, C, and C. Okay, why have we printed twice? Okay, we got P, and then we printed first K and that A, B, C. Why have we printed C twice? Then we get A. For A we updated it to 2003. Okay, and we removed B. The value for B was 2000. Then since after removing it became null. Okay, now that is working. I just am a pretty not sure about why we are getting the value of C. Yes, now it's working. Probably some heap memory issue there. Now you can see the proper implementation of this code. Okay, it will be available in my repository when this becomes public. It's currently private. It will soon become public. Okay, after I am done with the graphs and DP, I'll make them public. Until then, that's it for the video. Thank you.